Hi and welcome to this RIPEX2 tutorial on Babel protocol. This is part A of Babel tutorial series explaining how to configure automatic RIPEX2 mesh routing. Before guiding you through the configuration, I will briefly describe this type of connection and list scenarios where it is typically used. Babel is an advanced dynamic routing protocol addressing many shortcomings of BGP and OSPF protocols. Mainly, it has the ability to work with wireless links, which are by definition slower and more erratic than fixed links. RACOM introduced Babel in 2023 in both RIPEX and MIDGE product lines with continually expanding proprietary improvements built on top of Babel core technology. Babel is the next generation routing protocol suitable for all types of networks, high as well as low speed. Babel relies on periodic routing table updates in contrast with OSPF, which relies on updates sent only when network topology changes. That makes Babel much more flexible when data needs to be sent using alternate routes. This effectively enables the network to have automatic backup routes which are constantly updated. Real advantage can be felt when Babel manages not only the radio part of the network, but also Ethernet, cellular or fiber. Such a solution has the potential to be much more robust and self-healing in case of node failure. And all that without a need for operator intervention. In this tutorial, I will show you how to configure a dynamic mesh radio network using Babel. Please see our other Babel tutorials for more advanced examples. What will you need? While most examples can be tested with just 2 RIPEX units, we recommend using 4 units for comprehensive testing. These units must be in router mode and have the radio interface configured. See example configuration on the screen. We use flexible protocol on the radio channel, which allows full mesh communication. If you use base-driven protocol, you get automatically configured star topology. In our examples, we bridge all Ethernet interfaces and assign the bridge and IP address. In this table, you can see radio IPs and corresponding Ethernet IPs. In case you are not sure how to configure this, please see our basic setup tutorial. Now let's go to Unit A and go to Settings, Routing Babel to start configuring dynamic routing. First, we activate it, set the router ID to 111.1 and keep the metric of imported routes at 32. The metric of imported routes in Babel reflects the cost of a route. Lower values are preferred. Static routes with higher metrics, like 100, can serve as fallback paths while Babel is syncing after a reboot, ensuring temporary connectivity until dynamic routing is established. After activating the protocol, go to the Network tab and create a new network. The interface name must be radio, type wireless. We also changed the RX cost to 100, increased the hello interval to 30 seconds and set update interval multiplier to 4. Hello interval controls how often the unit will send out hello packets to determine cost of routes. Update interval multiplier controls period of sending routing table updates. It is calculated by multiplying the hello interval with this number. In our case, this means the unit will send out some Babel-related service packet every 30 seconds, and every 30 multiplied by 4, 120 seconds, it will send a complete routing table. Since there are 4 Babel nodes on the network, we can expect a service packet on average every 30 divided by 4, which is 7.5 seconds. More routers in the network mean more Babel overhead traffic. On the other hand, shorter intervals mean faster network change discovery. Always test and optimize these values to your topology, radio network modulation and channel width, and your SCADA traffic patterns. The golden rule is to leave over 75% throughput capacity for SCADA communication. In the Static Rules tab, add a rule with a destination 192.168.1.0/24. The default metric of 0 ensures this route has the highest priority, which can be changed later if you need to adjust route preferences. In the Import Filter tab, leave default settings for imported rules, which allows all routes to be accepted without filtering. Change the local preferred source address to 192.168.1.1 to ensure this IP is used for locally generated packets. In the Relay Filter tab, keep the default option Accept. With this setup, RIPEX unit will act as an active relay, forwarding learned routing rules to other Babel routers and allowing paths to pass through it. There are also additional filtering options available, such as setting specific filter policies, defining network conditions, adjusting metric values, and increasing metrics for forwarded rules. For this example, we will leave all these settings unchanged. And that is all for one unit. Go to Changes and send changes to the unit. Now, we need to configure the 3 other units according to the table on the screen. The process is the same. I will now power cycle all units and wait for them to boot up and connect. Pro tip! If you'd like to speed up network connection after power cycle, we recommend adding static routes as well. Set their metric higher than dynamically created rules. In our case, metric would be 150 or higher. Now, I will log into one of the units and go to Diagnostics, Information, Routing Babel. The status area shows 5 tables. Let's explain them one by one. Interfaces table shows all interfaces on which Babel is either configured or found. State tells interface state either up or down. RX cost displays configured neighbor received cost. Neighbors shows the number of detected neighbors on a particular interface. Time shows seconds until next Babel hello or update transmission, and next hop is the next hop address the router offers to its neighbors. Neighbors lists all detected one hop away units. Routes shows all routes from all neighbors. Please note that the asterisk in the F column marks active rules. Plus sign means it is the next preferred route. Babel automatically fixes loops, so do not worry if you see some in the table. Entries show active routers on the network with diagnostics information. The last table, Babel IPv4, consists of advanced and detailed information of all routes from the Babel table. Let's see whether the connection is working. Go to Diagnostics, Tools, ICMP Ping, and test remote stations. For example, 192.168.4.1. As you can see, the station response confirming our routing configuration is functional. I recommend watching part B now to learn about radio and relay filters, which are essential for successful Babel deployment in larger networks. And that is all I have for you today. Please have a look at our more advanced Babel tutorials and other learning videos here on YouTube. Thank you, and have a great day.